and welcome to my workshop. Today I'm going to do a 3D engraving in a rather thick piece of brass. Brass in Australia is extremely expensive. This is a piece of sheet that's 1/4 of an inch or 5mm in thickness, and I've got about a square foot of it. That's $250 nearly. So you know, you've got to go sort of real sparingly with brass, but the outcome in brass is spectacular. It's really beautiful. And it shows off what a well-made CNC router can actually do. Now, to get a good result, especially in metal, you need a good, solid, rigid CNC router. The majority of the routers that you do see for sale just won't hack it. Won't do a very good job at all. So be very careful what you purchase, because you could very easily be throwing your money away, especially if you think you're going to get a result like I'm going to show you now. So this is going to be a straight 3D carving into this brass. So I will be showing you the full setup of setting the machine up to do the job, the actual job as well, so there'll be some high-speed photography, and I hope you enjoy it. And if I get enough requests, the next video I will show you how to take a grayscale picture and put it into ArtCAM, treat it in ArtCAM, clean it up, and make a 3D relief, and we'll machine it in brass as well. So we'll see how we get on with this one. Okay, so the first thing we're going to do, we're going to take the router head or the spindle, and I've already got a tool, an engraving tool put in it. It's called a conical tool, and here's one. Very sharp. And the tool is in here. A bit small to see at the moment till I zoom in. So what I'm going to do is I'm going to take it over, and I've already pre-marked on the material the center of the program. Now in ArtCAM I made the start of the program in the center of the job, and it's going to spiral out. I find engraving into metal, especially if it's a circular piece, that is the best way to do it. Rather than go back and forward in the X, you tend to leave some lines. I'll zoom you in so you can see exactly where the tool's going, and you have to be extremely accurate with this because the whole relief is 40mm in diameter, and the Z is only 1mm. You know, the relief in this, so it's very precise. If you don't get it just right, you can muck it up. So here we go. Okay, so that's good enough for the X, Y. Now, this particular spot here is called the G54. This is the work offset. Now, when I say the G54, or commonly known as the 0 point of the work, now G54 offset is just really the code in Mach 3 that tells Mach 3 this is the start of the job. So you have to label it something. Now, the machine home position is here. This is where the the 0 point or the machine home position is here. And what makes, or where the name work offset comes from, it just simply means it's offset from the machine home. So it's really not complex at all. Okay, so now we're going to set the X, Y, 0. So now there's the machine offset. That is where the the machine home position there. So if we now we're indicating where the work 00 is, or the G54. So we go 0, 0. So now we set the X and Y 0. So the Mach 3 knows exactly where the X, Y is. So now we're going to tell it where the Z is. Now that's an automatic setting on this machine. I'll show you how to do that. Okay, so we start by lifting the tool up a ways. And there's about fine. So this is the Z tool height setter. So now we're going to set the automatic Z height. So switching to the Mach 3 screen, you'd go to the auto tool set, and the tool automatically comes down and registers the height in relation to the tool. Now, one last job that you absolutely need to do, well, I think it's necessary for you to do anyway, is go over to this little window here and regen the tool path. Now, you just watch what happens here on this screen. It's a big program, so it's going to take a minute. There you go. Mach 3 now has reconfigured everything with those settings that we put in there. So Mach 3 and the computer knows exactly what to do and where to do it. Okay, so the RPM of the spindle is set at maximum. In this case it's 24,000 RPM because you got such a very, very fine pointy tool, and we want a nice clean finish. So, and the step over is a very minute amount. It's about probably 10% the width of a human hair. So it's very, very small amount. Okay, so I'm also going to set the feed rate right down really low and let it come in quietly. All right, so we'll start the spindle up and we'll go for it. Oh dear, I've had a little bit of a disaster. 75% through, the end of the tool decided to snap off. Oh, if I can just show you that. You can see the end of the tool is missing. So it happens to everyone. I am no exception. I'll actually show you what it actually did to the carving. Hopefully that's not too glary for you. If you notice sort of in this area here, and certainly this area here and around there, it's sort of ragged. So I think part of the tip actually had come off, and it was doing a bit of a ragged cut, but you couldn't detect it. You know, it wasn't making any real difference in sound. And then it did make a different sound because it went very quiet. So there you go. That's what happens, but all is not lost. So what I'm going to do is I'm going to put a much, shall we say, much more robust tool. This is a 90-degree tool, engraving tool, so it's much more robust. So what I'm going to do is I will reset the zero much deeper, maybe 1/2 millimeter deeper than this, and of course I'm going to recut this, and I'll cut that section out. So, you know, all is not lost. You can sort of regain regain the piece, but it's just, you know, this is like 45 minutes into the cut, so it's 45 minutes of lost work. So this time I'm actually going to use a bit of paper to find the top of this material, and then I will adjust it in Mark III to take it 1/2 millimeter further down. So this is a very delicate operation, I suppose. So what I'm going to do is I'll take you up here to Mark III. Okay, so there's a number of things I'm going to do here. First of all, I'm going to rewind the program right back to the start. And that's simply done by going here, pressing that, and it's rewound it back to the start. The next thing I'm going to do now is reset the Z with this new tool in, albeit 1/2 millimeter lower than what the actual material is. This is really just to feel, you know, where the tool is rather than try and see it with your eyes. I've set the jog very slow. Okay, so that's the actual top of the material. So I'll just take you back up here to the screen. And incidentally, I've set the jog at a very low level here too. So I have full control over it. So set the Z 0 like so. Now I'm going to take it off that point, off that from that area, and take it further on down. Okay, so now I'm off the material. I notice it's moving the camera around quite a bit. So I'm going to trick it now to think that the material's actually a lot lower than what it actually is. So we come here to the Z minus. Okay, so that's nearly 0. So I'm going to take it down 0.5 millimeter now. Actually, maybe a little bit more. Okay, let's get more precise here by taking this down. I could actually write the number in there, but I'm being lazy. Okay. .5 maybe. .7. There you go. 0.7 of a millimeter actually deeper. Now that should get rid of all the messiness that's been left behind. So it just means we're actually going to be machining 0.7 of a millimeter further down. And we can now get rid of that and press for the new 0. Now I'm going to lift it up. Oh, I better reset the jog. Okay, so now we can restart. Okay, so that's the horse's head, and it's now come out beautiful. So now I've put a 6mm 2 flute end mill in. I'm just going to set the 0 up, the Z0, and we're going to cut this out. And that, ladies and gentlemen, is the result. It wasn't easy, as you could see, but hey, you know, we all have breakages, and you've just got to do it again. But thankfully I didn't waste the piece of material. I just set it 0.7 of a millimeter further down, deeper, and it's come out perfectly. If enough of you would like to, the next video, I'll show you how to put something like this together using ArtCAM in my case, if you wish. So just drop me a line, send me a message, and I'll see what I can do. So thank you for joining me for this video, and I hope you've enjoyed it and it's enlightened you a bit on the use of good little CNC routers. And like as always, be warned, there's a lot of rubbish out there. So be careful what you're buying. Thank you for joining me. Press like, subscribe. So all I've got to say now is bye for now.